All right, now we have got another particular question that we are going to work on, which is construction and LOCI again, from the question paper of November 2006, which is question number 6. It's very, very important that we revise such typical questions, even though it's from a long, long time, but it's very, very important. It's one and the same thing. If you check here, we are given a quadrilateral A, B, C, D that we are supposed to construct. All right, so let me just try to remove this part here. So we're given to construct the quadrilateral A, B, C, D, in which AB is 4 centimeters, BC 6 centimeters, CD 5 centimeters, and also the angle ABC of 135 degrees. Take note, and the angle BCD of 120 degrees. It's important, as I always say, that try by all means to indicate the angles or to have the angles on the base. The angles should be on the base. Yes, we can have our angles presented on top, but try by all means, if possible, that your angles should be on the base. All right, so I'm not going to waste much time. Let us quickly have our sketch here. So it's a quadrilateral and there's an angle of 135, an angle of 120. By just an approximation that you are taking into consideration, just an approximation, we can just say 135, something like this, to represent 135, and to represent 120, something like, you just know how the angles are. Like 135, it's more than 90, 120, it's more than 90. So if I choose this to be the 135, remember the 135 is on angle ABC. So meaning to say I'm going to maintain the order of A, B, C, from A to B to C to D, in that order: A, B, C, D as our quadrilateral. But angle A, B, C being 135. So this is going to be my 135 degrees. All right, then we have got another angle, which is BCD of 120. We are going to see this is the one that is already on the base, BCD. This is the one that you're going to have here of 120 degrees. Then we take into consideration the dimensions that we are given. In this case, the size that we are given: AB 4 centimeters, BC 6 centimeters, CD 5 centimeters. So we're going to label these dimensions. So as we saw that we are given AB as 4 centimeters, so this is going to be 4 centimeters. BC, it was 6 centimeters, and CD, it was 5 centimeters. So this is your sketch, the one that you're going to use in your on your constructions and so forth. All right, so let us see how we are going to end up with our diagram now, how it is going to look like. So we've got our instruments necessary for all the constructions as stated, our compass here and our ruler. All right, so we are going to construct the line which holds the points B and C. So this is our line here. I'm going to have our line just like this. Then we can mark the point, our reference point. In this case, we can choose to start with C or to start with B. So in this case, I'm going to start with the point B. So I'm just going to mark a point where I want to construct the angle of 135, which is at what? Which is at B. So from this point, this is the one that we are referring to as B. We are going to construct 135. Remember, the 135 is taken from 45 degrees. The 135 is from 45 degrees. We know that if we have constructed 90 degrees and we bisect this, if this is 45 degrees, then it means from 180 degrees, 180 minus 45 gives us 135 degrees. So that is the concept that we are going to apply. So it means in order for you to construct 135, you are going to construct the angle of 45 degrees, and 45 degrees is taken from 90 degrees. So you go back to the basics of constructing 90 degrees. Mark a point this side, also on the other side here. All right, with these 2 points, remember, open more than half of the line. So you're going to open more than half of the line, construct an arc on top, another arc down. But we have got a reference point, which is B, so there's no need for us to construct another arc down. We're just going to the other point, then construct back so that these two will join. like this. All right, so we have constructed, we have made the arcs which are necessary for us to have the angle of 90 degrees in this case. So what you simply need is to join to be, but being a broken line, because the 90 degrees, we do not need this, but it's just helping us to construct the 45 degrees. So I just prefer to have this as a broken line, since it is just helping us to construct the angle of 45. So as we know that from our construction, in order for you to have 45 degrees from a 90, you are supposed to bisect an angle that you are given, and to bisect is to divide into two equal parts. So you need to divide, but take note of where you are going to, it's not this side. If you bisect this, it means you have got 45 inside the shape. So it's going to be wrong. So you're going to bisect this side, so that 45 is going to be outside and 135 is remaining inside the shape, the one that you want. All right, so let us bisect our angle. Remember, to bisect an angle at this point, you are going to mark 2 points, 2 arcs from the lines which are creating the 90 degrees. Just locate a point which is continuous, like this one. We can mark an arc this side, and we do the same. All right, this one is not going to reach, so let me try to reduce my arc. So I'm going to use my arc here. I mark an arc here. I also do the same thing on this side. I'm going to mark an arc here. All right, so this is what we have from these 2 arcs that we have marked. These 2 arcs, we are going back to the 2 arcs. Then remember, construct an arc inside where you want your bisector to be at, which is this side. Then from the other arc, you do the same. You see that these 2 arcs will meet at a certain point. Like here, we join these 2 arcs, they meet at a certain point. Where these 2 arcs meet, that's where we are going to join in order for us to have the angle of 135 degrees, which is taken from which is simply taken from the angle of 45 degrees, like I was saying, to say these angles, what you simply need is to consider where are they taken from. All right, so I just need 135 here. Let me just change this 135. So it must be at the condition that we want. All right, 135, like this. All right, so I'm just gonna join this one. So on this one, it's accurate because here I can actually indicate 135 on this row, but as you can see, it's accurately the one that we are given here, and it is exactly the one that we got on the on this point. So meaning to say this angle is 135 degrees, as we have taken this angle from where? From this 45 degrees. As we are concentrating on the one that is remaining inside of the shape, which is the 135 degrees. All right, so that's it. We have got our B. So B, being our reference point, is the one that can help us to locate point C and to locate point A, because from B to C along this line, it's 6 centimeters. So what you simply need on your ruler is to measure using your compass. So you take your compass, put it on a ruler. Where you get the 6 centimeters on the ruler here, you now mark, like here, as for me, this is my 6 centimeters. So I'm going to mark a point along this arc here, along this line. I've got an arc. So I have got the point C in this case, because we know that from B to C, it's 6 centimeters. So we are going to have 6 centimeters. The same thing, B, along the 135 degrees here, there's an angle that we have. I mean, there's a distance that you're given there of 4 centimeters. So you're going to measure again on your ruler, 4 centimeters. Like for me, this is my 4 centimeters. So I'm going to use this 4 centimeters from the point B along this line, which is along the 135 degrees. All right, so mark the 4 centimeters on the line. That means you have the point A in this case. All right, so this is A being 4 centimeters from B. All right. Now, if we check, we have indicated this, we've indicated this. What is happening at C? At C, there's an angle there of 120 degrees. So you need to construct 120 degrees at C, the 120 inside of the shape. So how are we going to do this? The 120 degrees is taken from 60 degrees. The moment we construct 60, we are remaining with 120 from the concept of a straight line, because we are on a straight line. So you know that if this is 60, this one is going to be 120 degrees. That's 180 minus 60. So we are going to construct 60 degrees on the right side, on this side, so that 120 remains inside the shape. All right, so with your compass, remember how to construct 60. You need an arc, just a bigger arc that you're going to have like this. All right, then without changing this distance, mark where this arc and the line meet this point. Then we are supposed to have another arc to join the first arc that we had. So like I said, without changing the distance. So by doing this, these two arcs here joined point C, they create an angle of 60 degrees. So that's what we are going to have in this case. All right, so if we join these 2 points where the points intersect and the one at C, if we join this, we are having what? We are having the line which is taken from an angle of 120 degrees, which is the most important part, that this is 60 degrees, the remaining is 120. So as we are not indicating the 60, it's not part of our diagram. The angle that is part of our diagram is 120. So this is the one that we are interested in, which is 120. So it's now easier to find point D, because we know that from C to D, it's 5 centimeters. So you can simply measure 5 centimeters, because you know this is where the point D is supposed to lie, along this line. So you simply need to measure 5 centimeters on your ruler. All right, so here I've got my 5 centimeters. So with the 5 centimeters on your ruler, you now indicate or mark the arc along the line that is along the 120 degrees angle here. So by doing this, we have marked the possible position where the point D is supposed to lie. So the point D is supposed to lie at this point, which is 5 centimeters from C. So this point is 5 centimeters from C and 120 degrees from C. So that's the possible position for D. As you can see, to complete the quadrilateral, because we've got 1, 2, 3 sides, we can just join from C, from A to D using our ruler. So that is what you're going to have here. From A to D, we are going to join. All right, so let us see what we are going to have at the end. So this is A and D. Join the two. By joining these two, we have completed our quadrilateral in this case. So this is construction after everything that you have done. The lines that you have constructed, do not erase anything. Leave your diagram as it is. The examiner is going to see everything properly. Don't worry about those guys to say they are not going to see where the marks are. These are the marks. So if you erase anything there, you are erasing your marks. So leave everything as it is. All right. Now let us check what we have. We have constructed this part. We have got our 6 marks there. All right. Now we are given on the B part to measure and write down. So this is just you measure and write down the length of AD. So, all right, let's see on our diagram AD. So I said whenever you are to measure anything, you do not write it along the line to say, okay, I've measured AD, like in this case, I got something like 11,4. You don't indicate here 11,4. No, just write it as a point. This is our item B, item 1. So we obtained something like 11. So it depends with what you obtained there. But your values are not supposed to be more than like plus or minus 0.3. So here we're gonna have 11, maybe yours it can be 11,3, it can be 11,5. I don't know, because this part is being affected. You are not that accurate when you are constructed, but you are given a certain tolerance whenever they are marking these values. All right, so this is how you answer. Just write it aside. measure with your ruler, then you write it aside. All right. Then we have got D, BAD, angle BAD. So this time we need to measure the angle BAD. So that is another item, which is B item 2. All right, so we need the angle BAD. So what you're gonna need here is a protractor. From B to A to D, you place your protractor. So in this case, I got an angle, something like 50 degrees, but here, because of this shifting that I'm doing here, it might affect answer, but let me just show you how you're supposed to use your protractor. Using your protractor, make sure that this plus where these two intersect are at the point A, because we want angle B, A to D. So we are going to place this line covering from B to A. This part is supposed to cover B to A like this. This is where our point A is, like this. B to A, it must cover this line B to A. So you want to measure the angle which is taken from this point from B to A to D. So we are going to take these angles like 10, 20, 30, 40, 50. So it's going to be 50. So like here, because of these adjustments, it's going to be something like 50 something, but I don't know what exactly you are obtaining from your measurement, but that is how you take the angle. Make sure that you measure in a correct way. All right, so that is our part BAD in this case. Then we are given now on the C part. I want us to check this one carefully. We are now talking about locus. But the locus does not work alone. It goes with the construction part. We have to construct that locus that you are given, a position, just positions that we are talking about. So you need the locus of points equidistant from A, B, and B, C. And I said, whenever you're talking about two lines, whenever you're given two lines, these two lines, they create an angle, A, B, and B, C, they create an angle. So this one is an angle bisector. You have to bisect the angle. So meaning to say the locus of points equidistant from A, B, and B, C is going to be an angle bisector. Make sure that you have the notes on the locus concept, all right? So the angle that we are going to bisect is the one that is taken from, you take this part, A, B, B, C. There's a letter that is going to repeat there. Always there's a letter that is going to repeat. So meaning to say this B here is the one that is repeating. So you're bisecting the angle at B, which is the angle at what? At B, this one. All right, so we are going to bisect angle B from AB and BC. This is our lines AB, BC. So we need to bisect this angle. All right, so how do we bisect an angle? Remember, to bisect an angle, you're going to need this point, the point B. From point B, open a certain distance from point B to the line BC, which is creating our angle. Just mark a point. You do the same on the side of A, mark an arc. With these two arcs, without changing the distance that you have used with these two arcs, we are going to mark back the arcs inside where we expect our bisector to be, like somewhere here. We expect our bisector to be somewhere here. So the arcs are supposed to be somewhere where you expect the bisector to be, like somewhere there. We expect our bisector can be somewhere here. We do the same thing from this point without changing the distance, all right? Where this bisector, where you expect your bisector to be at, you join. If you mark an arc like this, you're going to see that these two arcs, they meet at a certain point. Where these two arcs meet, that's where we are going to join from in this case. So be careful on your bisection. Be very careful on your bisection. How you bisect an angle is very, very important. It's very, very important. All right, so here we need something like 67.5. The half of this one is gonna be somewhere here. All right, somewhere just a little bit. So you just need to join the 2 points. Like I said, they will meet at a certain point. So we are going to join. So this line is supposed to be big enough. Don't just join to the point, then you are done. You join up to this point, then you are done. No, extend that line. Just make it a little bit big enough. All right, so that was the locus that we are given. Locus of points equidistant from two given lines. It gives us an angle bisector. Then we are given now item 2, 3 centimeters from BC, but they did not end there. They are now saying and on the same side of BC as A. All right, if the statement was ending here to say 3 centimeters from BC, I said a distance that is taken from a line gives us a pair of parallel lines. We are going to have a line 3 centimeters this side, 3 centimeters this side, meaning to say these two lines will be parallel to BC. But now they are giving us a condition to say it's not only 3 centimeters from BC, it's also on the same side of BC as A. So meaning to say we are going to have a line that is parallel to BC, but on the same side where BC is to the side where A is. We are going to have 3 centimeters to the side where A is. So let us check our where on our diagram here. This is our BC here. So they are saying we need 3 centers from BC on the same side of A, meaning to say our line is supposed to be like this, parallel to BC, but on the top, on the side where A is, we are no longer having a pair of parallel lines like this. We are no longer having this. All right. So remember, how do you construct this part? So we are just going to measure 3 centimeters. They say 3 centimeters. So this is my 3 centimeters. You measure from your ruler. Then from point B, you just mark and you just draw an arc on the side of A. So the arc that you're going to draw, it was supposed to be a circle like this, like I explained in another video. But here we're just gonna have an arc, not a circle, something like this. All right, you do the same thing without changing this distance, still having your 3 centimeters at C, because they say 3 centimeters from what? From BC. So we are going to have 3 centimeters from C again. So this is 3 centimeters from C. So with the 3 centimeters from C that we have and the 3 centimeters from B, but on the side where A is, we are going to join these two arcs. They are backs here, these two arcs. By joining these two arcs, we are going to see that the line that we have just drawn is parallel to BC, but this time it's not we are not having two lines like I was trying to explain to say it's different from that part that we had two lines. So this is what we have. So the line that we have just drawn right now, it is parallel to BC, 3 centimeters from BC. That is what we are trying to say in this case. All right. So because of these measurements, it might not be exactly, but you are supposed to have 3 centers throughout, 3 centers throughout. That is to say a line is parallel to a certain line. They maintain equal distance throughout. All right, let us check the last loci that you are given, the last locus that you are given now. They are saying 4 centimeters from B. Remember, B, it's a fixed point. And I said whenever you're talking about loci from the locus from a fixed point, it gives us a circle. So we're going to have a circle of radius 4 centimeters from B. It's a fixed point, so we get a circle. So from the point B, you measure, they said 4 centimeters. So you're going to measure on your ruler 4 centimeters. All right, this is 4 centimeters. Let me cross check again. Is it 4 centimeters? All right, 4 centimeters from what? From B. All right, so you measure 4 centimeters. Then from B, you step the needle point at point B. You can draw a circle that is 4 centimeters from a fixed point. So what you are going to obtain there is a circle. All right, so that is the locus of points equidistant from a fixed point. So what you simply need to indicate is that when given A, it's a point. So we are talking about a point. A represents a point. When you are given AB, AB represents a line. When you are given A, B, C like this one, it's an angle. They are talking about an angle, the angle at B. When you are given ABC with a triangle like this. They say triangle, it's triangle ABC. So you need to know the indication of each. What indicates a point? What indicates a line? So if you are given now two lines formed together, A, B, and C, and you're asked the locus of points equidistant from these two lines, you have to bisect the middle part because we need distances which are equal this side and equal this side. So it's from the angle bisector. So that is another part that you just need to know. So that is what we had. Let's continue to revise as we are preparing for exam.